Okay, good. We are going to actually look at a paper here, grade 11. Okay, and we're going to go through these questions one by one. So this is the first question here. We are asked to solve for x. So this will be a good revision paper for any grade 11 student across the country who is preparing for their March control test, or any student that is in a program where you are going to be writing grade 11 papers this coming weekend, let's say perhaps, or any other learner that is basically in the country, in South Africa, that needs to just brush up on their algebra skills. So we are going to be looking at algebra, equations, inequalities, nature of roots, exponents, the works. Okay, I'm gonna take this paper through minute by minute, second by second, problem by problem, and hopefully we'll be able to get through it very nicely and seamlessly without really running into any major issues. Okay, hope you guys are ready with me. Let's get into it. Okay, let's jump into it then. 4x squared minus 100. We are required to solve for x there. Let's do this. So we are required to so there's the problem. It's 4x squared minus 100. So when we are looking at any equation and we are looking to solve for x, we first look, is the equation in standard form? Currently, as we look at this, it is in standard form, but I think we can simplify it even further. How? We factorize, meaning we take out the highest common factor if there is one. So in this situation, as you can see, there is a highest common factor. The highest common factor that is there is 4. So what we can do, since the highest common factor is a numerical value only, we can divide the equation for all terms by the numerical coefficient. Guys, we can only do that if the highest common factor is a number. If the highest common factor is not a number, we take out the highest common factor, because the number and the variable will lead to there's a specific answer that we are going to be getting by actually taking out the common factor as a number and a variable. So when it is a number, if the HCF is a number, we can in essence divide by it, right? We can divide by that number. So that's what we are doing here. The 4 and the 4 cancel, we are left with x squared. 100 divided by 4, a negative divided by positive is a negative. 100 divided by 4 is 25. Then obviously 0 divided by 4 is 0. So now what we have is the x squared minus 25. This standard form of our equation is actually more simplified. Okay, and it is a standard form that is simplified, that is easy to work with. So we have x squared minus 25. We can now factorize. The expression here on the left is the difference of two perfect squares. So what we can do now is we can open two brackets. The negative sign means we are going to have different signs inside the brackets. We write a plus and a minus. The square root of x squared, guys, is x. So we write x and x. The square root of 25 is 5. So we write 5 and 5. Make it equal to 0. Then that is basically us factorizing. Okay, so F for factorize, S for standard form, 3, we apply the zero factor law. Since we have two brackets of factors equated to 0, we take x plus 5 equal to 0, x minus 5 equal to 0. Then we go ahead and we isolate the x. X is equal to negative 5, or we isolate the x for this one. X is equal to positive 5. So these we refer to as our roots of the equation. Okay, and that basically is how we arrive at that answer. So if we come here, we can see the allocation is 3 marks. You would get 3 full good marks for your standard form, 3 full good marks for factorizing correctly, and then for your roots being 100% correct, you get the 3rd mark. So that would be 3 out of 3. That's marks in the bag, and I'm good to go. Moving on to the very next question. Okay, question number 1.1.2. 3 into 2x squared minus 5 is equal to x. That is question number 4. So let's write it down. We are solving for x still. 3 into 2x squared minus 5 is equal to x. So what we do first and foremost is we want to get the equation into standard form. So here we have some distribution that we need to do on the left, and then if it's a quadratic equation, we are going to transpose the x so that we can have a standard form. So let's first do the distribution. 3 times 2x squared is 6 x squared. 3 times negative 5 is negative 15. We transpose the x, we get minus x is equal to 0. Now the order of the terms needs to be in the standard form that we know. So we have 6x squared minus x minus 15 is equal to 0. This is our standard form. Okay. Then of course, now that we are at this state, we have a few options that we can take, right? And that is, we can factorize using an appropriate method, okay? Or we can what? Or we can use the quadratic formula. It's really up to you what you do from this stage, because of the grade 11 learner and the grade 12 learner, you can either factorize or use the quadratic formula. Okay, so most of you grade 11 will find it easier to use the quadratic formula. Okay, but we can also factorize this thing. Okay, so one of the methods is to use the trial and error method if you can, but guys, quadratic formula if you feel like all else fails. Okay, so we are going to get 3x and 2x, which are factors that actually work out nicely. Okay, then minus 5 and plus 3. That is because, okay, it doesn't work out nicely, sorry. So this doesn't work out nicely. Oh, it does, actually, because negative 5 times 2x gives you negative 10x. And 3x times x gives you plus 9x. And the addition of these two gives you negative x for the middle term. So it works out nicely. Okay, 3x times 3 gives you 9x, that's positive. Negative 5 times 2x gives you negative 10x. And the addition of these two gives you the negative x for the middle term. Whereas negative 5 times 3 gives you negative 15. So that works out nicely. Okay, so we have factorized successfully. Like I said, some of you may choose to use the quadratic formula. That's also fine. Okay. So we just need to make sure that you write out the full quadratic formula, please. You write out the full quadratic formula, then you substitute appropriately. Please, guys, a is going to be 6, b is going to be -1. There's a -1 there. C is going to be -50. Okay, so then you go ahead and you say minus, as the minus is there. B, you substitute using brackets. Okay, B, -1, the whole thing squared. 4 into A is 6, C is -50, all over 2 times 6. Negative times the negative is 1, plus minus. The square root, -1 is 1. -4 times 6 times -15 will give you plus 360 all over 12. So you have 1 plus minus 1 plus 360 is 361, which is all over 12. Then you can simplify this. Okay, 1 plus minus the square root of 361 over 12, which is the square root of 361 is 19. Two answers. X is equal to 1 plus 19 over 12, which is 20. 1 plus 19 is 20 over 12. And that basically simplifies to become 5 over 3. Why? Because the highest common factor between 20 and 12 is 4. 4 goes into 20 5 times. 4 goes into 12 3 times. So it's 5 over 3 over 12. Or, sorry, at this stage, or 1 minus 19 over 12. That gives you 18 over 12. In fact, -18 over 12, which simplifies to become -3 over 2. Highest common factor is 6. 6 goes into 18 3 times. 6 goes into 12 2 times. So these are the values of x if you use the quadratic formula, guys. So quadratic formula, please write it out completely. The subject of x must be there if you are going to choose to use the quadratic formula. And when you substitute, you use brackets. You substitute your b in brackets, your a and c in brackets, and then your a in the denominator in brackets. Then you simplify, so that you get a single value. Negative times negative is positive. One single value here, single value there, and a single value there. You can apply the square root. You can either use your calculator, or, like I said, you can basically showcase step by step. If the answer simplifies to a rational number, like 5 over 3 and -3 over 2, you must simplify until that rational number and not write decimals. So here, remember, we had expanded so that we can get the standard form. Then we factorized because that was another approach we could use besides use the quadratic formula. Okay, some people, guys, to factorize, they use the AC method. All right, but like I said, in grade 11, guys, you really can factorize, or you can go ahead and use the quadratic formula so that you can save time and not waste time using a longer method. Okay, but anyways, this method, trial and error, works for me. Then I apply the zero factor law, meaning you take each expression inside the bracket, equate it to 0. That is called the zero factor law, ZFL for short. Then now we can solve each linear equation. Isolate, take the -5 over. Isolate, take the 3 over, then we divide both sides by 3 for this side, we get x is equal to 5 over 3. Or we divide by the coefficient of x, which is 2 this side, we get x is equal to 3 over 2. So these are the options we have to solve for x when we have a standard form, which we feel like we can either factorize and get the roots, or we can use the quadratic formula and get the roots. Okay, let's move right along. Question number 3. Here, when you look at this question, it's very good to analyze a question. This is x squared plus x, the whole thing squared, plus 4 into x squared plus x minus 12. So the first thing you see when you look at this particular question, you're like, okay, it's 8 marks, but what do you see? Say you were to actually expand because you want to get your equation into standard form. You open 2 brackets for this. Your first term when you expand will be x squared times x squared, which will give you x to the power 4. That's problematic for us being in grade 11, because any equation that will have a leading exponent or the greatest exponent being x to the power 4, that means that we are going to have a problem with simplifying and getting the values of x. So the minute we can see that that is the case, we need to look at something else, and that is check if there's any repetition of an expression in brackets. So you can see here we have x squared plus x inside this bracket, and here as well we have x squared plus x. That is a repetition of an expression. Repeated expressions say to us that we need to employ a suitable method, which we refer to as the K method. So it is that very method that we are going to use here, the K method, right? Because we can see a potential x to the power 4 coming about when we open 2 brackets of x squared plus x. Because of the repeated expression of x squared plus x, we are going to let k be equal to x squared plus x. I suppose we choose any arbitrary value and substitute that. So we can let, guys, k be equal to x squared plus x, because x squared plus x is a repeated expression. Good morning, Sefamit. I saw you there in the comment section. I hope you're well. Then, by letting k be x squared plus x, we substitute in the place of k, in the place of x squared plus x, k. So this will become k squared plus 4. This is x squared plus x. We let it be k, repeated expression k, minus 12 is equal to 0. Now what we have is a standard form. Let us now, after getting the standard form, factorize the trinomial. And it's possible to factorize it, guys. Before we jump into opening 2 brackets, we must check if there are feasible possible factors of negative 12. We multiply them, we get negative 12. We add them, we get positive 4. Negative sign, if the factors exist, then we can open brackets. But if the factors don't exist, guys, we don't go ahead and open brackets, because that would be a waste of time. So factors of 6, we do have them. We have them indeed. The highest factor must be positive, so we're going to write different signs, because a negative constant means different sign, but the highest factor is going to have a positive sign. So we know 6 and 2 qualify. K, we are going to write k. Factorization is 100% correct. 6 times negative 2 gives me negative 12. A positive 6 minus 2 gives me positive 4 when I add it. Right? So then we can now apply the 0 factor law. After factorizing, we apply the 0 factor law as usual. We get k is equal to negative 6, or k is equal to 2. We we transpose the 6, get negative 6, transpose the negative 2, get positive 2. Then after so doing, we are now sorted. We have our k values. We need to now go substitute in the place of k these values into this equation. So we can now write x squared plus x is equal to negative 6, or x squared plus x is equal to 2. These are the equations we will be solving to get the initial values of x. Remember, k was just a temporary way. I'm sure you guys know the clothing brand K-Way. So K-Way, I usually say K is the way to X. It is not the final destination. K is the way to X. So when students usually get to these K values, they think, yeah, we've gotten the solutions. But then they forget that they were not trying to solve for K, they were trying to solve for X. Hence I say K is the way to X. So now we substitute back the K values in the place of that equation. Then we can now write this equation in standard form. But when we look at this, we're like, do we have any factors which when we multiply give us 6, when we add them give us positive 1? Such don't exist. Okay, and even if you use the quadratic formula, you would substitute and you'd actually find that. And I just want to show you guys this. Say we use the quadratic formula. Okay. In the place of b, we say 1 squared 4a with c over 2 times 1. The third case here is that inside this square root, we are going to have a 1 minus 24, which is a negative 23. And guys, the minute underneath the square root there's a negative sign, that basically tells you your calculator is going to give you a maths error, but that means we have no answer, there's no solution, there's no value of x that basically will satisfy this equation. So I mean, I was able to see that because factors don't actually exist. There's no two rational numbers or numbers irrational that you could multiply together which will give you 6, but at the same time when you add them will give you the coefficient of 1. So there's no real solution here. But this equation we can take and write in standard form. Negative means different signs. The factors of 2 which we multiply give us negative 2, but when we add give us 1. Those actually do exist, so opening brackets will not be a problem. So then factors, the highest factor will be positive based on the positive sign. Different signs, but the highest factor will be positive. So 2 is the highest factor and 1 is the smallest. We check. 2 times negative 1, negative 2. 2 minus 1 gives you positive 1. Then we can apply the 0 factor law and get our two solutions. X is equal to negative 2 or x is equal to 1. And those are solutions that work out quite nicely. How many marks was this? It was 8 marks. The method letting k, our standard form, our factors, our solutions of k. The standard form of one equation, the standard form of the other. 1, 2, 3, 4, 5, 6 so far. Then our solutions of x here. 7, and acknowledging that there's no solution there. 8. So 1, 2, 3, 4, 5, 6, 7, 8 marks. beautiful 8 marks. Beautiful 8-mark question there. Step by step, we get those marks. And those 4 marks, I did not add the 4 marks for 1.1.2. Let's just go back a little bit here. Writing the equation in true standard form, factorizing, of course, and my 2 solutions. If I go the quadratic formula route, still I get the mark for standard form. The quadratic formula, substituting, that's my second mark. And then, of course, my 2 solutions as well. So that would be 4 marks, as opposed to 4 marks of actually going ahead and using the quadratic formula. So this would be 8 marks, no doubt. So 4 out of 4, it's a nice feeling. And then 8 out of 8, it's a nice feeling as well. Okay, I think now we can turn over the page and we can go and see if we can answer the next question, which is, let's see, 1.1.4. Okay, yes, very too many marks. So 1.1.3, we had 1.1.3 we done. 1.1.4, 6 marks. We have x plus 2 over x plus 1 plus 3 over 2 minus x is equal to 1 over x plus 1. That is a equation that involves fractions. All right, so we have a method that we need to take very seriously when we do the question like this. And I don't know, no matter how many times I seem to suggest, I was teaching a few learners yesterday physically on a Saturday class, and yeah, I think I'm noticing that people fail to follow the method. So let's write the question: x plus 2 over x plus 1 plus 3 over 2 minus x is equal to 1 over x plus 1. First things first, step number 1, look at the denominator. I usually say to learners, factorize if possible. Look at the denominator, factorize if possible. You can apply the sign change rule when necessary. Now, factorization has your golden rules, which is when you look at factorizing something, you look at the expression that you want to factorize and you ask how many terms there are in that expression. You follow that up with, is there a need to apply the sign change rule? Then you follow that up with, if the sign change rule is applied, then great. If not, then you move on to the next question and you ask, is there a highest common factor? If there is one, you take it out, and then you leave what's left over inside brackets. Then lastly, you look at the brackets and check, can you factorize further? Or are there like terms that can be added or subtracted inside the bracket? If all of that is done and there's nothing more that can be done, you stop right there. But if you look inside the bracket and there's a further type of factorization you can do, like difference of two squares factorization, or trinomial factorization, or any other type, you do it, and then you stop when nothing more can be done. So those are like the golden rules of factorization, step by step. How many terms? You ask. You count the number of terms. Secondly, is there a need to apply the sign change rule? You apply it if it's necessary. Move on. Is there a highest common factor? You take it out if there is one. You leave leftovers inside the bracket. After you are done with that, you ask yourself, is there any other further factorization that can be done with what is in the bracket? If not, you don't do it. If you can, you do it, whatever type of factorization. So that means you need to know all your different types of factorization for that to be successful. You add and subtract any like terms if there are any inside the bracket, and then if there's nothing more that can be done, you stop right there. Factorization has been complete. So I say step 1, look at the denominator, factorize if possible, and by that I mean you go through the golden rule steps to check for each denominator if those things are actually there. So if we look at this, x plus 2, okay, In the denominator, we have x plus 1. Factorizing this means you put it in brackets because you're acknowledging that you are taking out the highest common factor of 1. That 1 does not have to be written down. We just know it's there. Two terms have now become 1 plus. Now, we have 3 over. This is 2 minus x. The order is not as sweet as we would want it to be. So we can apply what I call here the sign change rule. And this sign change rule applies for terms that have a negative sign in between. You simply take out a negative sign and then you change the order of the terms and you put them in brackets. Okay? This applies for two terms where you want to change the order and there's a negative sign in between. Take out a negative sign and then you change the order. Equal to 1 over x plus 1. Putting x plus 1 in brackets is factorizing it by taking out the highest common factor of 1. Now you have a positive and a negative sign. Those are next to each other. One's at the top, one's at the bottom. A positive divided by a negative. What does a positive divided by a negative get you? Gets you a negative 1, negative sign. So we have 3 over x minus 2 is equal to 1 over x plus 1. We are done with the factorization in the denominator. Step 2. LCD and restrictions. Lowest common denominator, okay, will basically be the product of your number, letter, and bracket that are common, but common not for every single denominator. Okay, we identify unique things in the denominator and we actually take out those unique bases with the highest exponent. So for instance, if you look at x plus 1, x plus 1 is common for these two fractions in the denominator. So that means x plus 1 is actually going to be part of the LCD multiplied with x minus 2. X minus 2 is unique. It's not common with any other bracket. So we also write unique brackets as a product to what is not common for every bracket. So common brackets with the highest exponent is the brackets we identify in this situation that will make part of our LCD. From the LCD, if you look at this bracket, you are looking for x values that will make this bracket be 0. So what value should x not be? X cannot be negative 1. Remember guys, if x is a negative 1, what's negative 1 plus 1? It gives you 0 in the denominator. We don't want our equation to have a x value at the end that will basically substitute and give 0 in the denominator. Why? Because 0 in the denominator means that the fraction is undefined. The entire equation will be undefined. So we write down a restriction to avoid values of x that will make the denominator 0. We then also say x cannot be positive 2 because 2 minus 2 gives you 0 as well. So these guys are what we call our restrictions. Okay, x cannot be negative 1, x cannot be 2. After writing those down, we can multiply now each fraction in the numerator, by LCD. So if we take this x plus 1, x minus 2, and we multiply it here at the top, all right, okay, we put 2 or more terms for each fraction, 2 or more terms in brackets. Okay, so x plus 2 is 2 or more terms. I'm going to put it in brackets. 3, not so much. 1, don't really mind because it's not 2 or more terms. Okay, that is a safe measure to take. So take this x plus 1 into x minus 2, my LCD. I put it here at the top. Who cancels out? If x plus 1 and x minus 2 are here in the numerator, the x plus 1 and the x plus 1 will cancel out because x plus 1 divided by another x plus 1 is 1. This x minus 2 is going to be left behind. So I have gotten rid of the denominator x plus 1 by multiplying by the LCD. Why do we multiply each fraction in the numerator by the LCD? to remove the denominator. We are actually getting rid of the denominator so that we can have an equation that we can solve that is workable. We multiply each fraction in the numerator by the LCD to remove the denominator. So it's happening. Take this, multiply at the top. Okay, who goes? He goes. Who gets left behind? He gets left behind. I call it the who goes and who gets left behind. In a relationship, some people have to go. There's people that get left behind. The people that go are the ones that are not necessary in your life anymore. The people who get left behind are the people that you need the most, who will actually be adding positive value in your life and will help solve some of life's problems. For instance, get you to the solution of x. So x plus 1, x minus 2, if you multiply at the top, who goes? X plus 1 and x plus 1. Numerator, denominator cancel. Who gets left behind? X minus 2. You see now x plus 2 is attached by multiplication to x minus 2. Let's go to the second fraction. You multiply all of this at the top. Who goes? X minus 2 goes. He cancels. Who gets left behind? X plus 1. We need x plus 1 in this new formed relationship. We take this, we multiply the at the top. Who goes? He goes. Who gets left behind? X minus 2. So we say 1 into x minus 2. Okay, hopefully so far we are together and we are understanding what's happening. We have just done what? Multiply each fraction in the numerator by the LCD to remove what? The denominator. Okay, we also take a precaution. We put 2 or more terms in brackets so that we know exactly. You see x plus 2 there at the top, we put in brackets so that we know exactly what is supposed to be happening with those 2 brackets. Now, 4. We want to achieve standard form. What is standard form? We want to get the equation into this form. So in order to do that, we are going to have to apply distributive law, FOIL. And when we multiply out, we don't forget the multiplication of the sign, the number, and the letter. X times x, x squared. X times negative 2, negative 2x. 2 times x, positive 2x, and 2 times negative 2, negative 4. Okay, that's multiplying out 2 brackets, applying the method of FOIL. First terms we multiply, we get x squared. Outer terms we multiply, we get a negative 2x. Positive times a negative is negative. 1 times 2 is 2x next door. Then we come to this term, we distribute it to the 2 terms as well. 2 times x, 2x, 2 times negative 2, negative 4. Negative 3, we do the same thing. Negative 3 times x, negative 3x. Negative 3 times 1, negative 3 is equal to. Do the same thing here. 1 times x, 1 times negative 2, x minus 2. We are close. Standard form, I am smelling you. We transpose and add like terms. Minus 2x plus 2x minus 3x, we bring you closer. X, transpose the x, it turns to negative x. Minus 4 minus 3, take the negative 2 over, it's plus 2. Now we can add the like terms. 2, negative 2 plus 2 is 0. Negative 3 is negative 3x, minus x is negative 4x. So x squared minus 4x. Then minus 3 minus 2 is negative 7. Negative 7 plus 2, negative 7 plus 2 is negative 5. Standard form has just been achieved. 5. We need to factorize. This is a quadratic equation. Its constant is a negative. Last term is negative. We check, do we have factors of 5? When we multiply, we get negative 5. When we add, we get negative 4. Yes, we do. 5 is a prime number. 5 and 1 are the only factors of 5. But a negative 5 plus 1 will give us a negative 4. So that means we do. So opening brackets is legal. Negative, positive, 5, 1. X works out nicely. Then we apply the zero factor law. We then get our x values. Isolate negative 5. X equal to 5. X is equal to negative 1. Before we complete, so factorize, we done. Zero factor law, zero factor law. Knowing that if we have a product of factors, we take each factor, if there's a 0 on the other side, we take each product, each factor, equate it to 0. Then lastly, 7. We solve the linear equation to get our roots. X is equal to 5, x equal to negative 1. 8. Check your roots against the restriction. So that's why the restrictions are important. We are going to check our roots against the restriction. So if we go and we check, where is our roots? There are our roots. Against the restriction, x cannot be negative 1 and x cannot be 2. Why are we avoiding this? Because we are trying to avoid having 0 in the denominator. In our solution, is there any value that goes against the restriction? X is equal to 5 is fine, but x is equal to negative 1 is not fine because x cannot be negative 1. So what we do is we align our answer with the restriction. And that, guys, secures full marks. The full 6 marks. Okay. Let me just suggest what would be the mark allocation. Applying the sign change rule for your factorization of x minus 2 here. That would be 1 mark. The elimination of the denominator, that would be a 2nd mark. Then you FOIL and you get to standard form. Getting to standard form, would mean that your distribution and everything has gone 100% correct. Getting your factors and then the 2 solutions and making sure that one of them is eliminated or is not regarded because of the fact that it goes against the restriction. So please, guys, when you do fraction equations, do take care to follow the steps so that you can attain all the marks that are due to you, right? So 6 out of 6, this one. It's a champ, it's a winner. Okay, it's a winner. And you can see I've basically spelled out the steps for you so that you don't go wrong. Okay, so if there's a place where you feel like, hey, you may find yourself going wrong, like for instance, you don't know how to identify the LCD. Guys, the LCD, you identify the product of the number, the lowest common multiple number, which is usually a number that would, if there was a number before the bracket, then you would actually find the lowest common multiple number, which you then multiply with the lowest common multiple letter. Usually, sometimes, for some brackets, there is a letter outside which you are going to compare and find the lowest common multiple letter. You then multiply that with the lowest common multiple bracket. The product of the lowest common multiple number with the lowest common multiple letter with the lowest common multiple bracket is what forms the LCD. The composition of the LCD is formed by that. Then you write your restrictions based on the LCD. If the LCD is complete, your restriction should be fine. But also, you have those things to look at as well. Okay, 1.1.5. Let's answer 3 more questions, and I think we are going to end this live for now and pick it up at another time. Okay, the same paper at another time under different conditions. Okay, square root of x squared minus 63 minus 4, root x is equal to 0. Okay, this is another solve for x question, and it's for 6 marks. So what we are going to do is we're going to look at this, and we know that this is a surd equation. Surd equations have a systematic flow whereby one, we need to first isolate our surd. Isolate the surd. The word isolate means the surd must be alone. So here currently we have a square root of x squared minus 63, but it's 1 minus is another term of 4 into root x. So currently you could say two terms of surds are isolated, but I think we can do one better, which is we can literally isolate the square root of x squared minus 3 alone, and then the square root of 4 root x. See, when the negative 4 root x goes over, it becomes positive 4 root x. Then after doing so, we are going to square both sides. And when we do, the square root of the square gives us x squared minus 63, because the square root and the square, they cancel each other. You apply the square root, the square to the square root, the square and the square root cancel each other. Here we have 4 multiplied to root x. Guys, because the relationship is one of multiplication, for when the relationship is multiply, we know that we can distribute the exponent n to a has the exponent 1 and b has the exponent 1. So 1 times n is n, 1 times n is n for b. When there is division, you can also do this. The distribution of n to the exponent of 1 for a, the same with b. So we can do this with multiplication and division of bases, but we never guys do it for addition and subtraction. We don't distribute the exponent. Here we open the number of brackets that we see the exponent shows, okay, or we apply an appropriate exponential application to what we have. So we don't ever, guys, this is rubbish, that when there's a plus and a minus you want to do this, okay, doesn't flow. Okay, so here you have 4 and root x. So 4 is multiplied with root x. So if you apply the square there to 4 squared, then you apply the square to the square root. So you have x squared minus 63, okay, which will give you 16. The square to the square root. Okay. So step 1, you isolate the surd. Step 2, when the surd has been isolated successfully, you square both sides. So this is what we just did, squaring both sides. Why? To eliminate the root, because it's a square root in this case. So we do that, guys, until we don't see a root anymore. Okay, it's possible in a third equation to square not only once but several times in an equation, depending on the square root's stubbornness. Now that we are here, we are chasing standard form. X squared, take the 16x, negative 16x minus 63 is equal to 0. Now remember, I said to you, we can open brackets when we are confident and clear that there are factors of 63 when we multiply together will give us negative 63, but when we add we get negative 16. Those factors don't exist here in this situation, right? So after the quadratic formula, we know we either factorize, after the standard form, we know we either factorize or apply the quadratic formula. So here, this is a situation where we are going to apply the quadratic formula as step number 4. So let's do that. X is equal to minus b plus minus b squared minus 4ac over 2a. Quadratic formula should be in your mind and heart. It should be like flowing in your blood. So negative the b is negative 16 plus minus b squared negative 16 squared in brackets. Please guys, when you substitute, you put it in brackets, because not putting in brackets means something completely different. Okay, 4ac over 2, the a1. Then you go ahead, a negative times the negative is a positive, negative 16 squared. Okay, maybe you don't know, so it makes sense when you say brackets negative 16, you square it, you get 56. Okay, 256. So Sekhamete, just something to note. I saw you said 9 and 7, but remember, this negative sign means that your signs are going to be different inside the bracket. So think about it. Your signs are going to be different inside the bracket. So you are saying 9 and 7. But if your signs are going to be different, this negative sign means that your biggest number is going to have a negative sign. So that's going to be negative and positive 7. Adding these two, does negative 9 plus 7 give you negative 16? No, it doesn't. Okay, so that's why I'm constantly saying to students that, guys, please take note of the sign of the last term. The sign of the last term will tell you something. Sign of the last term is negative, that means different signs inside your bracket. Then this sign means the highest factor is going to have a negative sign. So if you're identifying 9 and 7, remember the product needs to give you negative 63, which it does. The addition needs to give you negative 16, which it doesn't. Negative 9 plus 7 gives you negative 2. This is negative 16. So you cannot use negative 9 and 7. I am an advocate that when people factorize a trinomial, before you become excited and open to brackets, first check, do factors actually exist? If they don't, guys, don't waste your time, because for instance, I had learners yesterday. I sent them this to do in my group, WhatsApp group. So I sent them to do, then some of them responded, very excited, and I checked this question in particular. Most of them were making the error of actually writing 9 and 7, but they were not cognizant of the signs. So that's why you need to have, when you are wanting to become an expert in factorizing, please take note of the last term. Negative last term means different signs. But remember, the biggest factor will be according to the sign of the middle term. If you have a last term that is positive, that's when you know that the signs are going to be the same inside the bracket. Okay, according to the sign of the middle term. So that's why 9 and 7, we just throw it out, completely. Okay, then negative 4 times 1 times negative 63, back to the quadratic formula. Negative 4 times, that negative 4 times the 1 times the negative 63, we get 252. Okay, that's positive 252 all over 2. Adding 252 and 256 gives us 508 underneath the square root. So 16 plus minus 50802. So I'm going to take all of this, and I'm now going to basically, not waste time anymore, and I'm going to get the answers that I need. So there's x is equal to 8 plus the square root of 127, or you have, you change the plus to minus, because that plus minus will help you to get the other answer. X is equal to 8 minus the square root of 127. So you have an irrational number answer. But now, guys, with surd equations, standard form quadratic formula, you get your roots directly. And then with surd equations, we need to always check our solutions to see which one actually stand, because there is a root and the root may do funny things. Okay, so if you took this, for instance, 8 plus 1, 8 plus root 127. Let's take this 8 minus, let's take this solution and just check it if we substitute in the original, if it will actually yield the results that we need. This we are going to square, and then we are going to minus 63. It gives us that, right? A negative underneath the square root. That's problematic. The minute we get a negative under a square root, guys, is problematic, because applying that root means we are going to get a non-real solution. So that means this solution here is not going to work, this one. X cannot be that, right? Let's take 8 plus 2 root 7. I mean 8 plus square root of 127. 8 plus square root of 127. Yeah, let's square it. Okay, and then let's subtract 63. Okay, so that answer, so we're going to take that answer, we are going to take the square root of that answer, because this is underneath the square root, and we are going to check what we get. 17.555, right? Then we are going to subtract 4, so we're going to minus 4 root what? The x. Remember, the x is 8 plus the square root of 1 plus 8 plus square root of 127. Just want to check. Oh, look, we get a 0 there. Minus that gives us 0. So this answer works. Okay, but let's just check what it is rounded off to 2 decimal places, because remember, we were not told to leave our answer in simplified surd form. Okay, so if we are not given an instruction in the question to leave the answer in surd form, then we need to actually get the answer into decimal form. So let's just go there and say 8 plus root 127 equal, then we press SD so that we can get 19.26. We round off to 2 decimal places. The 9 says 126, go up by 1, so it's 19.27. So x is equal to 19.27. This is an acceptable answer. Let's just change that plus to minus so that we can see what would have been the decimal number for the other one. Negative 3.27, or x cannot be equal to negative 3.27. We check our solution at the end. For surd equations, guys, we always check. So for surd equations, you first isolate the surd, as we did here. You square both sides. Why? To eliminate the root. So we squared both sides, and immediately the root was eliminated on the left. And then here, the square was applied to 4 and to the root. We got 16x. So the root was eliminated on the right as well. Then after that, we try and get standard form. Transpose the 16x, x squared minus 16x minus 63 is equal to 0. We get the standard form. After getting standard form, we factorize if possible, or apply the quadratic formula. Factorization did not fly, okay, and for reasons I explained. Quadratic formula flies. Okay, we write down the formula with the subject x is equal to. Too many people, when they write this formula, don't write x is equal to. Remember, you check the predominant variable in your standard form, and you align the subject with that predominant variable. Okay, so since it's x here, you write x. If it was y squared minus 16y minus 63, you'd write y as the subject. If it was k squared minus 16k minus 63, you'd write k as the subject. That is something else that people need to take into consideration when using the quadratic formula, right? The subject of the predominant variable. You substitute a, b, and c. A is 1, b is negative 16, c is negative 63. You substitute correctly using brackets. You simplify. you get the answer. You use the third, state of the equation of the answer of the root to go and substitute into the original equation and see which one satisfies the equation. So when we substituted 8 plus root 127 in the place of x, we saw that it satisfies the equation, we get 0. But when we substituted 8 minus root 127, it does not satisfy the equation. But we were not told in that question to leave our answer in said form. Nothing, no instruction. So therefore, we need to round off that answer to 2 decimal places. But what we did do is we did actually at least use the third form state to help us with our substitution, because that irrational number that is decimals like that, it wasn't going to help us, that one. Well, it would have probably, but it's just that it's too many values. Okay. Yeah, so I hope that makes sense. How many marks? 6. How do we get those 6 marks? Isolation of the third, squaring of both sides, standard form, okay, substitution into the quadratic formula, values of x, and the one that does not qualify because x cannot be. So x being 19.27 and checking the one that is not qualifying. Sometimes both qualify, sometimes one qualifies, sometimes both don't qualify. So you must always check. Third equations, you must check. Please check the answers for third equations. Okay, so we only have the third equation where you have to check whether you like it or not. And then your fraction equations, we always check against the restriction. All other equations, there is no need to check. So it's only when you have a third in the mix or when you have a restriction that you've written down for a fraction equation. Check as a matter of rule. Okay, guys, I think I'm going to actually now do the last two. Okay, please, if you can share this live, share it with others. If when I'm done, obviously the live uploads onto my channel as a live video. I'm actually going to look for an appropriate thumbnail and actually attach this, and I'm going to save it as grade 11 revision term 1 for all students in SA. Then what you can do is you can share the link of the live so that others can actually watch. I think this is a beneficial live, and to have devoted 1 hour and something minutes to actually looking at the explanation. I think someone who has forgotten can actually be retaught. All right, I'm going to do 1.1.6 and 1.1.7 at least up until there, and then the rest I'm going to do probably tomorrow morning. Okay, I think we can have this series start so that people can get prepared. 1 minus 2x into x minus 4 less than or equal to 0. This is an inequality, right? And it is quadratic in nature. Now, guys, I just need people to be careful with these inequalities. Okay, very careful. When you answer inequality questions, be very careful. So currently, there's something that is a warning to you, and that is, you can see here in this bracket, this is 1 minus 2x. But this 1 minus 2x, you can see the x variable has a negative coefficient. That should be sirening an alarm to you. Okay. Negative coefficient of x inside the bracket means that something is not right. So that needs to be fixed. Negative coefficient inside the bracket, negative coefficient of x inside the bracket, that needs to be corrected ASAP. So the sign change rule, can be very helpful in that situation. Okay, just for that bracket, guys, just for that bracket. So if we apply the sign change rule, what we are going to do is we are going to fix the order of 2x minus 1. Just that bracket. But for that bracket, because we fixed the order, what do? We take out a negative sign. Are you with me, guys? Sign chain rule. Okay. I think this is like for me the shortest cut because already there's a 0 on the other side. So we just simply apply the sign chain rule. Okay. Typically, when we solve a inequality, we want standard form. We want factors or factorization. And then 3, after factorizing, we write down something that we call the critical values. Right? We write down something that we call the critical values. So hopefully, yes, I'm glad you are with me there because this here, like I said, I sent this to my group of grade 11 learners yesterday. Okay, a certain group of learners that I'm teaching from various schools, and I was like, "Aibo guys, what is this now?" Right? Some of them directly went and wrote down critical values from this, with this situation still there, and it was this situation that led to their downfall, and I gave them 0 marks, you know, after all that effort that they had made, which was wrong. So that's why we need to be very careful. If you have a product of factors already, because we are actually here at this stage already with this bracket, there's a 0 on the other side. But the only problem is that this 1 minus 2x, the 2x has a negative coefficient. We can't have that be. We can't let that be. So we apply the sign change rule for the purpose of making sure that our product of factors, look, first and foremost, we have x term for each bracket to begin with. Our constants are on the other side. They are the second term in each bracket. And so we take out a negative sign so that this negative sign does not change anything. Because you take the negative back, you get negative 2x. Take the negative back to negative 1, you have positive 1. So taking out the negative is just a precautionary measure we take so that we can actually ensure that we are moving in the right direction moving forward. So now that we are here, what do we do? The negative sign cannot stick around when we are talking about inequalities. So there's one person who can decide to take this route, and that is divide both sides by a negative. When you do that, what happens? You divide by a negative left and right. You are going to get 2x minus 1 into x minus 4. Then the inequality sign changes direction. The inequality sign changes direction. You reverse the inequality sign. Some of you may be wondering, what is this thing of inequality sign reversing? Guys, let's just take an example here. Let's say we had a negative 5, and we say negative 5 is less than 3. I'm sure you all agree that negative 5 is less than 3. Negative 5 is a smaller number than 3, isn't that right? Okay. Let's just say 10. Negative 5 is less than 10. Okay. We all agree that this is a smaller number than 10. Negative 5 is a smaller number than 10. Let's say I said let's divide both sides by negative 5. Let's divide both sides by negative 5. If I did that, let's say I divided by negative 5 both sides. What's a negative divided by negative? It's a positive, and that's what's 5 divided by 5, it's 1. And let's say I kept that inequality sign as it is. Did not change it at all. What's 10 divided by negative 5, guys? It is negative 2. My question is this statement true? Is this statement true? Is 1 less than negative 2? Is that a true statement when it comes to numbers? Is 1 smaller than negative 2? That is the question. Okay, you see, I divided by negative 5 both sides for the numbers that you had initially, which were negative 5 is less than 10. I divide by negative 5. So the resulting answer is 1 less than negative 2. So we know that this is a false statement. What would make this statement true? what would make this statement true since it's a false statement? What would make it true? What would make it true is if I changed the direction of the inequality sign. So 1, if I said now, is 1 greater than -2? Then you are going to say, yes, sir, it's true. So that's where the idea or the concept comes from, that whenever you divide an inequality, whenever there's a division in an inequality by a negative sign, the direction of the inequality sign is reversed. Okay, so that's where that mindset or that concept comes from. Okay, so I hope you guys will never fight this thing again. The minute you divide by a negative, the inequality direction sign changes. But dividing by a positive, guys, let's say the same story. 5, let's say 5 is less than 10. And then I decide to divide by, sorry, let's say -5 is less than 10. Let's say then I give the instruction, let us divide both sides by +5. Now we are dividing by a positive number. Okay, we are saying let us divide by a positive sign. So when we divide by +5, we get -1 is less than 2. The question is this still true? Is -1 still less? Is -1 really less than 2? Is it? Is -1 really less than 2? Is -1 a smaller value than 2? Okay, is it true? Because we are dividing by a positive. Okay, so here you can see that the statement is still true. Dividing by a positive does not require us to reverse the inequality sign. But dividing by a negative requires us to reverse that inequality sign immediately. So that is why, guys, I divided the entire expression on the left by a negative. The inequality sign is reversed. Then we continue, and after factorizing, and we can see coefficients are positive, nothing in the bracket is negative, we can then go ahead and do what? We can find our critical values. Guys, when you find your critical values, this is simply you saying 2x minus 1 is equal to 0, or x minus 4 is equal to 0. We can go ahead and get the values of x. Okay, if we isolate, divide by 2, we get x is equal to half. This is our first critical value. And then for this side, we get x is equal to, we transpose the -4, get x is equal to 4. Some people don't show the steps when they've written critical value. They simply write the roots, x is equal to half, x is equal to 4. That's 100% correct. Showing the steps. Remember, when we're writing critical values, we are ignoring the inequality sign. We are simply wanting to know what are the critical values. What are critical values, guys? Critical values are the roots or the x-intercepts. These are simply roots or the x-intercepts of a parabola. Okay, that's what they are. Okay, and this is just it's kind of like a isolated, interjection. It's like an ad. When you're watching a movie, you have an ad break. This is like the ad break of the entire problem, because it is, as we are moving here, this is so different from what we've been doing above. Okay, standard form and factorizing, all right, was just the steps, but then critical value is like an ad break. You take this 2x minus 1, all of a sudden you don't say greater than equal to 0. No, you write equal to 0 because you want just the values. You want to know what are the values. Why? Because step number 4, you are going to then show your graphical representation of those critical values on a parabola or a number line. So you then draw a horizontal x-axis, you have a parabola, then you note your smallest critical value here as your x-intercept here, and then your big critical value as your x-intercept there. Then after doing so, let us interpret what this, our factor brackets that has a positive coefficient that's no longer negative, we are going to interpret what greater than or equal to 0 means. Okay, so greater than or equal to 0 means two things. Greater than means where y is positive. And y is positive, guys, on a Cartesian plane. Let me just show you. On a Cartesian plane, you have the y-axis, you have the x-axis. Your y values are positive here. Your y values are negative down here. This is above which axis? The x-axis. That's where your y is positive. It's above this axis, the x-axis. That's where y is positive. Okay, so that was why I'm saying when you interpret greater than 0, just greater than 0 alone, let's forget about equal. Greater than 0 alone means where y is positive. Where is y positive? Above the x-axis. Okay, then let's look at equal to 0. What does equal to 0 mean? It means on the x-axis, where the critical values are, on the critical values on the x-axis. Okay, so you're looking at two things here. Greater than 0 means above the x-axis. That's where y is positive. Equal to 0 means on the x-axis. It's on the critical values. So we come to our parabola graph. Okay, and the whole intention, guys, of actually ensuring that the coefficient of x is positive, not negative, and then dividing by the negative and the inequality sign changing, was so that at this state, the representation of our graph represents, at this stage, a, if we distribute, is positive. That is a smiling face. So we can write our x-intercepts, the critical values here and there. Small critical value, big critical value, where we are smiling, because at this stage, a is successfully positive, and what we are looking at is we are looking at this condition where the product is greater than 0. Greater than 0, what did I say means? It means where y is positive. Where is y positive? Above the x-axis. That's what greater than 0 means. What does equal to 0 mean? It means on the x-axis. So on my graph, this is where we are greater, above the x-axis. This is the x-axis. This is where we are above. What x values show the function being above? It's where x is less than who? Half. This region is where x is less than half. We go from here, we move in that direction. You can see the function will continue to be above infinitely. So x is less than half. Or this is also above. That's where x is greater than 4. So we have just accommodated the concept of x above the x-axis here. What about equal to 0? We said on the x-axis, which means on the critical values. So we are going to then have to add equal underneath and equal underneath, so that that is also accommodated, because on the x-axis, we are also looking for that as well. Okay, so that is our answer. Please, guys, read properly. X is less than, these values that are this side of half are less than half, and they are the equal sign means on the x-axis equal to half as well. We include half. or x is all these values this side are values that are greater than 4, and then on the x-axis we are exactly on the critical value. That is our answer for y being positive above the x-axis. I usually say to students, away from the critical values. Away on this side, away on that side. That's why I usually call this a above the x-axis, a away from the critical values. All right, so hopefully this is clear. Clear. People have questions? I hope to answer. So yes, please guys, when you are given in this state, we check where are we at this stage. We are kind of already here. The only problem is that we are wanting the coefficient of x to not be negative inside the bracket, but to be positive, and for it things to be in the right order. So here, where we are, we need to apply the sign change rule, as we had said. We take out the negative for this bracket. Guys, when you take out the negative, you are taking it for one bracket. You know, this negative is not going to be taken out for both. No, it's just this. Okay, yeah, and don't worry, taking out this negative sign is not going to affect the x minus 4 that you have there. No, it's safe. Okay, you are taking it out for 1. Okay, and then factors, we are now truly at the factor stage because all our x terms have positive coefficients. That's what we want, because a has to be greater than 0 so that our graph can be concave up. All right, I just prefer to teach that concave up, guys. And you know, I know there's situations where people write concave down. People would write a concave down graph here, you know, because they will look at this stage. They'll look at the critical values, still the same critical values, but then concave down, okay, at this stage because of the fact that the coefficient is negative. Then they are going to look at less than or equal to 0, which means below and between. Below the x-axis, less than 0 means below the x-axis, and then obviously equal to 0 on the x-axis. The answer will still be the same. You'll still fundamentally get the same answer, right? Okay, then the last question for the day is agreed. 4x squared minus 1 is less than or equal. No, 4x squared minus 1. 4x squared is less than or equal to 1. Okay, so here, let's just say here 3 marks, 1, 2, 3. This would be the 3 marks that we get. They actually allocated 3 marks, which I must say, I believe is a very scanty amount of marks. If you ask me, I think definitely 4 marks would have been worthy to be allocated for this 1.1.6 in my estimation, but the person who set the paper said 3 marks, so that's how we would allocate it. This answer carries the majority of the marks. Everything else is the way to the answer. But please guys, most learners, they draw the graph, they forget to write the answer. I remember a year when I had a student that got he was one of my top students in the class. He got 148 out of 150 for paper 1. It was in grade 11, and the reason why he got 148 is because in an inequality question he omitted to write the answers. He drew the graph, and I think when he had the critical values in his head, he thought those were the answers, but they were not, and he forgot to write the final answer. So he lost the 2 marks there. Got everything else correct in the paper, but lost marks there. 2 marks gone, 148 out of 150. He was devastated because there was another student in the class that got 150 who was not a regular 100%er. Got 150 out of 150 because he capitalized, I guess, and got right what he got wrong, and got right everything else. So let's look at this one. 4x squared less than or equal to 1. First step for inequalities, standard form. Let's achieve that. 4x squared minus 1 less than or equal to 0. We are in the standard form state. Second step, factorize. This is a difference of two perfect squares. 4 is a perfect square. X squared is a perfect square. A variable raised to an even exponent is a perfect square variable. 1 is a perfect square. So we are going to open two brackets. Okay. Square root of 4x squared. So we first write plus and minus because the last term is negative. That means positive and negative. Then we take the square root of 4x squared. That gives us 2x. The square root of 1. That gives us 1. All right. Then from there, what do? We apply CV. Guys, this CV must be written as a matter of rule because you are not wanting to actually write down the solutions as the critical values. Remember, I said this is an add break. Okay, so now we are actually wanting to write 2x plus 1, 2x minus 1, and solve for x. We divide both sides by 2, we get x is equal to negative half. That's our first critical value. Then our second one, divide by 2 both sides, we get x is equal to a half. These are not the solutions, these are just the critical values. So we write CV. Okay. Now these are the critical values. Now remember, after we are done with that, critical values, we remember what are those? They are the roots of the x-intercept of the parabola. So the next step is graphical representation. Smallest critical value on one side, biggest critical value on the other. Then next, we come here, we interpret what the inequality in the factorized or the factor stage is. So there's the inequality. Less than or equal to 0. What does less than mean? Less than means below the x-axis. That's where y is negative. Okay, guys, y is negative here, right? Below the x-axis. Equal to 0, what does that mean? It means on the x-axis. So we do this below the x-axis, and then equal means on the x-axis. Where are we below, guys? Below, we are down here. Okay, and that is basically between, right? So that's where x is greater than negative half. If you read from the middle to the left and then to the right, x is greater than negative half. Values that are greater than negative half are values that are lying here. But x, the same x, is less than half. Values that are less than half are on this side. So that's where we say they are situated. Okay. So below the x-axis, that's where y is negative, and that is interpreting less than 0, because anything less than 0 is something that is negative, and this being the output, it means y is negative. Where is y negative? On the Cartesian plane. It is negative below the x-axis. That's where y is negative. So then what do we say? We say below the x-axis, y is negative, and then equal means on the x-axis. That means we include that. So on the x-axis equal means we write equal as well, because equal is there. If equal was not there, guys, we wouldn't write on the x-axis. We'd basically have just less than, x is greater than alone, negative half, but less than half without the equal sign. That would apply even for the problem above. There's no equal sign, it means we don't check on the x-axis, you know. So that's why I call this one below the x-axis, between the critical values. So I usually call this BB. B, below, and between. Okay, guys, but this is only your situation where you have two critical values. Two critical values. Below means below and between your two critical values. If you have two critical values for greater than, That means I said above the x-axis, away from the two critical values. Okay, so we have AA above and away, and we have BB below and between for two critical values. And that's kind of how I help my learners to remember so that they don't forget, because yeah, I don't know how many times you have to remind learners of this. So standard form, your factors, your critical values in-housed in the answer, 2 marks that you get for the final answer. Okay, and that's 4 out of 4. Who can cry and complain? Okay, 3 out of 3 here, 4 out of 4 for different questions that basically have been answered 100% beautifully correctly. Okay, so I'm gonna end right there, and I'm gonna call this part 1 for today. Tomorrow we'll do the next and the next and the next until we complete everything that is supposed to be done here. Thank you so much, guys. Hope you have a wonderful, amazing day. Happy Sunday. God bless. May you be enriched, whatever it is that will basically be constituting what you will be doing today. I'll be going to service later on, midday. So you have a beautiful one, and I'll see you when I see you again. For the next part, which we'll be doing definitely, I think tomorrow morning, we'll continue this grade 11. I think it's good. Okay, please do comment, like, subscribe to the channel, share the channel with your friends, whoever they are, grade 11 friends, 12 friends, anyone who's basically learning the basics of mathematics. Share it all far and wide, and please do comment in the comment section and so forth in the video itself when it actually is uploaded. Okay,